それでは時間になりましたので。
Ladies and gentlemen, we would like to resume the program and begin session 2B, efforts to strengthen the supply chain participation in overseas projects. We will look at the industrial efforts in participating into projects outside of Japan. Again, this session will be facilitated by Ms. Hiroko Kondo from Matrix K. Ms. Kondo, the floor is yours. Thank you very much. I have the honor of continuing as a facilitator in this session as well. We will look at what the industry is doing, trying to make inroads into international projects. I'd like to first invite each panelist to share with us their efforts. First, the expectation to the Japanese companies from the outside view. We have Dr. Haijen Pan from Holtec. She is the executive director. Dr. Haijen, the floor is yours.
Good afternoon, everyone. This is Haijen Pan from Holtec International. Holtec, we are the design authority of SMR 300. I would like to take a minute to introduce you about Holtec. We are a technology company started in 1986, and we are a turnkey supplier to the nuclear industry. We do design, engineering, licensing, manufacturing, site services, and we are the turnkey supplier. Our company, on this side, it's showing our facilities. This it just to show you our international location. The one thing I want to emphasize that at Holtec, we own 5 nuclear power plants, 7 units that are in US. Holtec, we have our integrated management system. Our QA and safety has been accepted by US and international over 20 countries. Here I want to give you a brief introduction about our, I would say, key technology or the key supply. On the left, on the right side, top is the heat transfer equipment we provide to nuclear or non-nuclear industry, and we are the spent nuclear fuel and waste management provider. Over 40% of the world's commercial spent nuclear fuel actually is stored using Holtec technology, and we manufacture, do the construction, site services work to the nuclear power plants. And most important, starting from 2018, we become the Part 50 licensing holder and owner of the sites that 5 sites, 7 units in US. And we, with 8-year accelerated decommissioning plan. Oh, I'm sorry. So actually, SMR 300 is a national progression for Holtec's technology portfolio. So Holtec SMR 300, it's 300 the PWR reactor. It's designed based on proven technology. We are using most standard 17 by 17 spent fuel, 17 PWR fuel. And our system is designed with inherent safety. And this system, our 300, is passive, completely passive cooling under accident condition, which leads to this unlimited coping period. One thing I want to also mention to you that the Holtec team will include Mitsubishi Electric and Honda ENC and Pharmaton. So our 300 SMR 300 provides 300 megawatts electric and 1,000 megawatts of process heat and power for the grid, data center, and industrial use. The small area of the EPZ that leads to it can allow to be located in the industrial area and provide a clean steam to for flexible technology platform for diverse application. So overview of our program. We self-funded for the first 10 years by Holtec and our strategic partner. Currently, we are supported by US government and UK. The uniqueness of our program is our, the technology have inherent safety, and it's very practical to operate. Because our technology is based on our operation experience, based on the proven flexible PWR technology and the existing licensing basis. Our team all have proven, team members, they are the proven companies in their area with strong financial balance sheet, and we have the financial and owner option. Let me very quickly go through this. That licensing-wise, we already started formal pre-application engagement with UNRC. Another important thing is our SMR 300. We involved in UK general design assessment. It started in last year, October. We are planning to restart one of decommissioning Palisades site, and then at the same time, we are planning to construct 2 SMR 300 units utilizing the existing environmental and the security program, and so on. Okay, let me go to the, this is our SMR delivery organization, and this has a clear, defined division of responsibility. You can see Mitsubishi Electric is our ENC partner. So Holtec, we plan to manufacture and deliver our all the large reactor components. We have the existing facility can manufacture some equipment. We plan to develop the Holtec heavy industry to manufacture 2 units per year. 2 units per year, it's not able to keep the pace of the need of the world. So we need the partner for the equipment supply, and that one, what, it's not going. So looking at your nuclear energy policy direction in Japan, that's how lead to the cooperation discussion with the MEDI. And the last year, August timeframe, MEDI leads the nuclear industry to visit our facility in Camden, New Jersey. We were very impressed and by your quality and the capability, and we are looking forward to the long-term and further discussion with the suppliers in Japan, and we hope for the cooperation. Thank you.
ありがとうございました。
Thank you very much. Next, with regard to participation in international initiatives, from Mitsubishi Electric, Mr. Hamamoto, please. Good afternoon. I am Hamamoto from Mitsubishi Electric. I'd like to talk about nuclear business and in our company and our initiative with Holtec for SMR 300.
So this is the agenda that I'm going to be talking about today. I'd like to talk about my company first, and also the history of nuclear projects over the past half a century, and also since 2016. We have started a collaboration with Holtec for SMR 300 related equipment. So I would like to talk about that as well. So first of all, I'd like to just share with you the organizational structure of Mitsubishi Electric and also our nuclear business. So in our company, under the CEO, there are 9 business segments, and it's categorized into 4 business areas. So as to efficiently conduct business, infrastructure, and FA, factory automation, and automotive, that's included industry, mobility business area, and then life business area and business platform business area. And we are belonging to the industry mobility business area. We are in the electricity and industry systems group. Now, about our nuclear business. As indicated here, in Japan, we have a nuclear business. The Mitsubishi group of companies are collaborating together to provide seamless services from design, manufacturing, construction to after-sale services. So MHI is in charge of reactors and steam generators, and also leading the overall plant management. And then we at Mitsubishi Electric is providing a monitoring and control systems for the plant, turbine generators, transformers, and other electrical instrumentation equipment. And this slide talks about how our products are being utilized and installed in a nuclear power station. So this is very busy, but number 1 here, that is the main topic for today. This is the monitoring and control equipment for the plant, and also the main control panel. And major electrical components would be the turbine, generators, and also number 3 and 4 in this diagram, switchgear and transformers that are located outdoors, and large-size transformers as well. So we provide these various electrical equipment to the nuclear power station. Now, let me now talk about the history of our nuclear business at Mitsubishi Electric and how we are collaborating with Holtec company. So this summarizes the history of our nuclear business at Mitsubishi Electric and how we intend to deploy our business going forward. So we are looking at the developments in the nuclear industry as a whole, and we have been deploying businesses proactively in Japan and outside of Japan. And we are in line with the changes of the time, and we have been maintaining and strengthening our resources, supply chain, and technological capabilities. And let me just go over this in a chronological order in this next slide. So in 1970, we started out with a Mihama Unit 1 of Kansai Electric, and all the way up to 2009 of Tomari Unit 3 of Hokkaido Electric. We have been participating in 24 reactor projects for PWRs. And we have acquired technology from U.S. companies in the early 1970s. And towards domestic production, we have been able to increase our technical competencies, and we have achieved a full domestic production.
で80年代からは係争制御システムのデジタル化
In the 1980s, we have started a digitalization of I&C systems. In the Tomari Unit 3 project for Hokkaido, we have fully digitalized our I&C control systems. Next slide. So in the digitalization of the I&C systems, we have achieved full domestic production, and we have started to participate in overseas new build projects and have started to accumulate know-how. And in 2009, the Chinese National Nuclear Safety Authority have granted us the licensing for our I&C systems. And you see this towards the bottom of this slide. And in Japan as well, after 2000, we have been engaged in major upgrades projects, such as digitalizing the main control panels in existing reactors. And also, we have been contributing to the safety enhancement activities to comply with the new regulatory requirements. So, and we have been able to digitalize some of the analog products, which was also facing the risk of parts obsolescence. And in 2018, the NRC of the United States also granted us a licensing for our INC product. And based on that, the licensing from NRC, we have started to collaborate with Holtec and have been able to participate in this SMR project. So based on the experience in Japan and also overseas in the new build projects, we are now able to engage in business in the United States. So this talks about the objective of us participating in the SMR project and how we are collaborating with Holtec. So in 2016, September, we have started to jointly develop the monitoring and control system for SMR 300. In September last year, as was mentioned in the previous presentation, within the Palisades site, Holtec has decided to construct a SMR 300 reactor. So we are now in the process of accelerating our activities in design and licensing. So we are now able to get into new territories overseas, and also we are trying to maintain and further strengthen our technical competencies and also to enhance our supply chain. Next slide. So this is a project structure, and we are part of this project structure. We are sending our engineers to this project, and we are now engaged in the details design of the area. And through the collaboration with Holtec, we have had a great deal to learn, which is summarized here. So as was mentioned, the monitoring and control system is what we are engaged in, and it plays a very significant part in the plant operations and control. So in the design of this monitoring and control systems, it is necessary to understand the design philosophy of all the components in the plant, and would have to be in good interface and coordination with all the other equipment and facilities. As you see here in number 1 and number 2, we have to fully understand the design philosophy of Holtec, and also we also need to feed to Holtec side our INC system philosophy. So there would have to be a cycle and a very high quality communication, and by building a good relationship of trust, we'll be able to optimize the design. So we are now in a process of understanding the design philosophy of SMR 300. So going forward, let me just summarize our future steps. So towards the construction of a SMR 300 reactor, we want to make sure that we are able to gain the necessary design, licensing, and the delivery of equipment, and the technical competencies as a resource and supply chain that we have been able to foster through our experience in the past. We want to utilize that in this SMR project, so that we'll be able to establish ourselves as the world-class INC manufacturer, and want to feed that back to the future projects within Japan as well. Thank you for your attention.
ありがとうございました。
Thank you very much.
続きまして、
Next, from Japan Atomic Industrial Forum, Senior Managing Director, Mr. Akihito Uetake will make presentation. Over to you. Good afternoon. I am Uetake from JAIF. Now, I'd like to share with you our forum's efforts to strengthen international collaboration and support entry to overseas market. Next page. After next, please. So we are talking about 4 multilateral approaches and 2 bilateral examples. First, G7 International Nuclear Energy Forum at Sapporo. As a side event of G7 Sapporo Energy and Environmental Ministerial Meeting on April 16th this last year, JAIF and NEI co-hosted the International Nuclear Energy Forum. Well, they are called Sapporo 5 now, but the 5 countries excluding Germany and Italy and 100 from the industry have participated. And you have well-known CEOs and CNOs have come all the way to Sapporo. And in the presence of energy ministers of those countries, there's industry organizations from 6 countries, including us, issued a joint statement and talking about international cooperation, support for nuclear supply chain as a determination of the industry, and the request to the governments for utilization of nuclear power. And we were able to show that we have taken the leadership, but what was important is that this joint statement has triggered the getting of more countries to be involved. Now, on September 28th of last year, we have also the G7 meeting, the first of the meeting of OECD and AI presentation was, or the conference was made, and we were also issuing the joint communique. And those prior efforts have been successfully reaped at COP28, which was held in Dubai, UAE, at the end of last year, and I participated in this event in 9 days. The declaration to triple nuclear power was signed by 25 countries, including Sapporo 5, and it had a great ambitious goal, and there are many countries that participated, so it had a great impact. But as an industry, in response to this declaration, we put together the pledge for nuclear industry, and 120 participants actually signed and endorsed. And in the history of the COP, it was the first time that a positive assessment of nuclear energy has been included in an official document. So we have been working closely with government affiliate agencies, and we have made this effort flowing from the Sapporo to Paris to Dubai, and we also worked with the government-affiliated nuclear companies in UAE, the host country at COP, and we would be very happy if these activities have been contributed in any way to the fair evaluation of the nuclear energy. Now, the last one was the World Nuclear Exhibition that was held in Paris every 2 years, WNE. So Mr. Barr from JEFEN, who made presentation in session 1, actually represented JEFEN, and it has organized this as the world's largest nuclear industry exhibition. 88 countries and 780 exhibitors participated with 23,600 visitors. So management skills of organizing this event of JEFEN is really impressive. And we participate in this every year to introduce our member companies. And many companies visit our booth, and that has indicated the high interest in Japanese companies by overseas companies. And France, UAE, and Brazil are actually asking for collaboration with Japanese nuclear industry. And at WNE, we were able to feel the passion and zeal of the world in the nuclear industry that is really seen in Japan, and it has been further enhanced. And this is the floor map, and the total floor area is more than 35,000 square meters and 120 times as large as this room, and accommodates 3 grounds of Tokyo Dome. And this Japanese exhibition area is 81 square meters, France 2,300, and China 438, Korea 200. So considering the high capability of Japanese nuclear industry and high expectation by overseas, it's a bit sad. And for Japanese companies, WNE participation is a very good opportunity to enhance their distribution channel in overseas. So you don't have to be an exhibitor. You can participate just in this exhibition to have networking with overseas companies. So if you're interested, please contact us. And we are conducting business exchanges bilaterally with many countries, and we've been continuing this for over 30 years with France, and there have been co-organization of events 7 times with UK, and also we have helped them with business matching as well. And this is the initiative of with UK and Canada. So every year we co-organize Japan-UK Nuclear Industry Forum, and there were 12 pairs of business matching interviews, and online presentation that was done for the first time this year had 16 companies making presentations with 148 participating as an audience, and I thank very deep support from the UK Embassy. And in Canada, there was the first event that was held in Toronto and Ottawa, and 7 Japanese companies that had made presentation and exchange of views with Canadian companies. And so we are continuing with these efforts going forward, so I encourage you to take part. Last but not least, so in 2022, we've launched the website, Nuclear Industrial Directory of Japan. And this actually has the function of matching buyers and suppliers, and only membership companies can get access to the bulletin board, and overseas companies can offer their procurement information and partnership request. And as of the end of February this year, the number of companies registered is 62, and 19 overseas companies are registered. And in September last year, this has been integrated with the nuclear supply chain platform. So there's information from the government, and our function of matching with overseas companies is both provided on a single website. So I hope you can take advantage of this. That's all. Thank you.
Thank you very much. I would now like to invite Mr. Katsutoshi Ueno, who is the head of sales and director at Japan Steelworks M&E. Good afternoon. This is Ueno speaking. Thank you very much for this opportunity. There are 2 things I'd like to talk about. One is about our company, Japan Steelworks M&E, and our experience in participating in one of the missions. So our company, Japan Steelworks, was established in 1907, and in 2020 we formed this 100% subsidiary, which is just JSW M&E. So we are headquartered in Muroran. We also have the works there. The sales office is in Tokyo. We also have a sales office in Kansai, which is in Osaka. This shows our Muroran works. So the site is about 1 square kilometers, so 23 Tokyo Dome Stadium will fill that. And there are about 1,400 people working there. And so the point is that we can actually complete the production on that single site. And let me go into some of that details. To the upper left side, we have 120 tons electric furnace, so we will melt the scrap and material, and then that will take into the smelting reactor. And under vacuum conditions, we will adjust the ingredients or the materials and remove the impurities, and we can develop steel ingots up to 670 tons large. And then we have this 14,000-ton hydraulic forging press, two of them, and the 3,000-ton capacity oil hydraulic press. And we can forge them, and then we can apply heat treatment. And we also have machining facilities as well. Towards the right-hand side, you can see the reactor pressure vessel materials. And we also develop generator shafts. The generator shaft is 274 tons heavy, and then towards the lower right-hand side, we have the bottom petal. You can see small nozzles. Those are integrally carved out, and that actually single piece weighs 80 tons. So the RPV and the steam generators, we have this track record. Bluish part shows the components for the RPV, and the yellow part shows the steam generator components. So we started this back in the 1970s. We have supplied more than 3,000 items. And in the 1980s, after Chernobyl and 3 Mile TMI, there was a lull in the overall industry, but the new builds did continue in Japan, so we were able to survive. And then there was this replacement demand, and people were talking about the nuclear renaissance, and we made some capex. But then in 2011, after what happened at Fukushima, things went down. And so you can see how our demand has fallen significantly. But then I think there is a renewed appreciation of nuclear energy, and we are actually manufacturing, and those are to be sent to France and UK. And so in Milan, we are actually providing, making components that are to be used in the EPR2. And we are expecting more to come. The last slide is about us joining the mission to the United States. So the advantage is that we got the opportunity to make our case to the potential large players, and we were able to meet so many people in a very efficient way. We were able to develop connections with key people. And this is an all over Japan effort, so it was kind of very easy for us to participate. We were also able to learn from our peers, other companies from Japan. And the Secretariat was very supportive, and the program was very well organized. They even provided us with the minutes of those meetings. And they also arranged for interpreters, and they were very good interpreters. And so with all that help, we were able to actually develop new business. So currently, we actually have received inquiries for potential use in SMR. And so for us, this was a very successful participation. Thank you very much.
ありがとうございました。
Thank you very much. Next, I'd like to invite from TLV Sales Solutions, Mr. Nakashima. Nakashima-san, please. Thank you. My name is Nakashima from TLV, and thank you for this opportunity. I'd like to talk about our participation in the mission to the United States. As for our company, just very briefly introducing my company, we were established in 1950, and after that, we became Fujiwara Works for some time, and then in 1972, we renamed our company TLV. And we were originally established in Kakogawa City of Hyogo. So a little west of Kobe. We have 500 employees currently, and we are primarily manufacturing in valves. So that's the main part of our business. But valves that we make is different from what TVE is manufacturing. We are in the steam-related valves. So the condensation between the liquid phase and the gas phase of steam. So we are really specializing in steam trap. And the vendors who are here today, since the 1970s, we have been working with these vendors. As soon as atomic power generation started, we have been contributing to the industry. And we are having these locations in Japan. So this is basically in steams. Half of it is basically in the petrochemical industry. A majority of our business is related to petrochemical industry, but this steam is used in various places in the infrastructure. So in areas like food industry, our systems are being used, and we have locations throughout Japan. And but we don't have a location in the capital of Hokkaido Prefecture, not in Sapporo but in Tomakomai. So we're not necessarily located in the capitals of each prefecture. And also we have locations around the world, recently primarily in the Middle East. So we have deployed business abroad. And since the foundation of our company, we have two slogans. One, to pursue our unique characteristics, and the second one is quality first. So that is the basis of our operations. So to pursue our uniqueness, we have acquired more than 4,900 patents, and also utility models as well. And also we have been certified with ISO 9001 and 14001 until 2020. We used to have ASME N stamp, but as has been mentioned, because of the 2011 incident, we do no longer have that stamp. And the company name TLV actually stands for Troubleless Valve. That is the commitment of our founder. So I've been talking about a steam trap. So this is a supply line of steam and the valve in that line. So the requirement for the steam trap is not to leak any steam, but to drain the water continuously, and also have a long life of the product, and at the same time maintain the initial performance. So the requirements of the customers is that they want to provide a dry steam to the turbine and no problems with a drain line. So this is something that we have achieved with our domestic technology. And we have designed this steam trap, and we have a 90% market share today in Japan. And so there are some new regulatory requirements in place, and this is applicable also to valves. And so if there's a tsunami, there should be a valve to suppress the effects of the tsunami, and we have already delivered such products. However, 2011 incident, nevertheless, had been a significant incident for us, and since then, as was mentioned earlier, there have been major dip in demand from the utility industry or the power industry. But the METI official actually came to visit our head office in Hyogo Prefecture, and also we are now asked to engage in business overseas. So there are a lot of offers to us, and also there are a lot of expectations. There's more appreciation for nuclear power in the world, and we are now having contact with the global plant vendors, and we are also having more exchange with companies of different sectors and in the same industry. However, we have a lot of anxieties. For example, I do not have the English capability to make presentations in English, and I'm not sure if people would be interested in our products because our products are such niche products. And I don't know if our experience in Japan can also be applicable overseas. So in August of 2023, together with some of you here, we have been able to participate in this mission to the United States with a great support from the Secretariat. And the contacts were selected in advance, and we had a great consultation before the presentation in the content of the presentation. We also had a very good simultaneous interpretation. So we were able to successfully participate in this occasion. So we are still having approaches to our proposition. And also we are now having a mid and long-term planning with the involvement of the local sales companies. And ultimately, we have now some developments which lead to our future, which was unthinkable this time last year. So it was very successful for us, and I look forward to having better conversations with all of you here who are here today. Thank you very much.
Thank you very much. Now, based on the presentations made, I would like to ask for the input from panel members. As a new panel member, the Director for International Affairs, Nuclear Energy Policy Division of METI, Mr. Satoru Yasunaoka, will join us as well. And I'd like to get started with all the panel members. First, joint establishment of supply chain with international collaboration. From Holtec, Ms. Haijen, I would like to ask this question. Holtec had an opportunity to exchange views with Japanese companies in August last year, and you have a lot of construction projects globally, not just in the US. So what is your expectation for Japanese companies?
Thank you. So we believe that a reliable supply chain forms the cornerstone of the power generation infrastructure. We always wonder that whether we have enough resource and capability to develop the clean energy that can keep pace with ever-growing demand. So for our SMR particularly, it's also a concern for the SMR initiative, and our SMR design capitalize the approved design and leveraging the existing supply chain for the conventional nuclear power reactor plant reactors. So during the last visit, that when METI bringing the Japanese nuclear technology and equipment suppliers to our campus, their exceptional capabilities and qualification left a lasting impression on us. We believe they can provide invaluable contribution to our nuclear industry, and it must be neutral and sustained. So the demand for SMR exceeds the capability of our existing team. We believe the collaborating with multiple suppliers for each scope of work is necessary, and we believe that the Japanese suppliers will be, collaboration with them is necessary and promising. Thank you.
ありがとうございました。
Thank you very much. Then Hamamoto-san from Mitsubishi Electric. Holtec expressed her expectation for Japanese supply chain. So based on that, what would be your determination going forward? Well, thank you. We are part of the supply chain players, and technological product capability and human resources development is something that we have to focus on. However, for these activities, new plant development is indispensable and a must. So in recent years, those opportunities have become few and far between, and in order to maintain our technological capability, this has presented a challenge for us. So in order to have those opportunities to develop new plants, in 2016, we decided to work with Holtec to take part in overseas projects with co-development so that we can be exposed to cutting-edge nuclear reactor development and maintain and enhance our technological and product capability. So for SMR, there are a lot of equipment and components, auxiliary equipment and materials that are adopted in the plants. So there will be a lot of opportunities for Japanese products to be adopted. And as I said, as for overseas quality standards and codes, the certification and qualification efforts are something that would discourage many suppliers to participate. So we are introducing those so that Japanese products will be broadly adopted. I think that would help also enhance the whole industry level as well. So starting from the certification all the way to the collaboration with Holtec, we have learned a lot. So working with METI, we'd like to take advantage of what we have experienced and accumulate the meaningful expertise further.
サプライヤーの海外企業へのアピールの取り組みと成果についてご意見を伺います。まず TLV
I'd like to transition into what Japanese suppliers can do to try to sell themselves into the international market. So I'd like to first invite Nakashima-san of TLV. So what made you actually decide to join that event when some companies may actually be hesitant? Right. As I mentioned earlier, after what happened in 2011, the demand in the domestic market just plunged. Against that backdrop, we started to think about maybe potentially going internationally, but then at the same time, there were some hesitations because we understand that the market is quite demanding, and we are really focused on a very niche, small market niche, which is specific types of valves. So obviously, we did have some concerns, but then the Agency of Natural Resources and Energy was very proactive and enthusiastic, and given that very thorough outreach and support, we decided to move forward. And actually, for example, in the past, we have the ASME stamp that we actually let lapse, and because of that experience, we are now motivated to try again and perhaps expand our horizon further. Thank you very much. So let me ask Ueno-san from JSW M&E. So JSW is really a world-renowned company. Everyone knows you, but you still joined the event in the United States and Canada. Perhaps can you tell us why you did that and what did you gain from that? Right. With regard to the new design reactors, the so-called first-of-a-kind ones, we have actually been supplying for effectively all of them. And we would like to continue doing that for SMRs as well. But then there was COVID, and the connections and communication we had with through our old network sometimes were lost, and that's why we decided to join that mission for the United States. And obviously, it was easy to join because it was an all-Japan team, and it was very good experience. So we chose to join the mission to Canada as well. And we've actually made progress. We have some NDA signs, and we are also in negotiations with actual projects. So it was very fruitful indeed. Thank you very much. Now let me ask Uetake-san from JAIF. So what would be your views on supply chain support for the industry-wide scale? Right. As I mentioned earlier, we have many opportunities to come in touch with international or overseas associations of industries. And they have this great sense of trust, confidence, and reliability to the Japanese companies. And I think that's really outstanding in comparison with other countries. So we have this strong momentum for nuclear energy, and there's a very high level of expectations from the international market to the Japanese societies. So I'm trying to communicate that level of enthusiasm that's out there in the international market to the Japanese suppliers. And with this nuclear supply chain platform, we at JAIF are serving as the joint secretariat with METI. And so we hope to leverage our connections with the international industry community and the WNE and other bilateral opportunities. We would like to provide more of them so that we can support the Japanese supply chain going international. Thank you very much. So we would like to transition to wrapping up the session. In this session, we looked at Japanese suppliers, companies, and JAIF. We were able to get input from different perspectives. So last but not least, I'd like to invite Yasuraoka-san from the Agency of Natural Resources and Energy about what type of support or what frameworks you are thinking about. Yes, this is Yasuraoka speaking, and I am really the salesperson for the Japanese industry. And thank you very much for your presentation. I really have little to add.
But it is true that in New Jersey and Washington, D.C., we visited 4 American companies in August last year. So it is a kind of a reunion in this serum. And Haichin from Holtec, for this particular seminar, has traveled all the way from the U.S. to Japan. So I'd like to thank her especially for her contribution. And this private-public mission was well received in Canada. There is a different type of SMR, large-scale reactors, and there is also an initiative that we are encouraging Japanese companies to do to apply a wedge on that. And also UK, France, and UAE are actually asking for collaboration for with the supply chain in Japan, and this could be a new initiative. So there are a lot of inquiries and requests that we receive. But this is just a public forum where there's cheerful and promising, encouraging talks, but it's not easy, as you all know. And overseas projects are coming up, but there are a lot of things that could stand in your way, and things may not go as you had expected. So the codes and standards and certification and qualification is really a challenge, as Nakashima-san said. ASME code certification could cost you a lot just to maintain it, but in order to knock on the door of overseas business, you have to get qualified first, and so that's a challenge. And for those countries that are introducing nuclear power for the first time, they would like to introduce the local contents as much as possible, and that's what we hear often. And looking back, that's what we did in Japan as well. So how to hit the right balance between this wish and the Japanese company's entry. And for each country, when they are going to procure which parts, the procurement timing is also difficult to understand. So if you don't know those timings, if you just blindly approach the countries, it won't work. So there are various overseas projects where you get stuck at somewhere down the line. So at the best timing, we would like to encourage the best, good, excellent Japanese suppliers to go and get the foothold. And that's what I felt. And as was said in various presentations today, as METI, we are working with JBIC and MEXI to provide ECA finance. And also, we'd like to give support for human resources development and code certification so that they can make necessary investments with minimum risks. And we are quite aggressive in coming up with some ideas so that companies can take initiatives that will be effective. So you have to take root and turn to the earth away from just a word, superficial word and phrases. And thank you. Thank you very much for your summary. With that, I would like to conclude this particular session. I'd like to thank panel members and audience in the venue and the audience that are participating remotely for their contribution and presence. Kondo-san and panel members, thank you very much. So all the panel members are going back to their seats, so please join us with a big hand once again. We'd like to take a break at this point and get started with session 2C from 20 minutes past 4. And students are in a separate room for this session. And there's a nuclear supplier joint job fair that will be held in the room that you will find when you turn right. And there are valves, pumps, and steel materials and electricity and instrumentation, maintenance. There are many vendors that are representing those industries that are making presentations together with Pastor exhibition. And those that are participating online from 15:15 with a different web link, you can also take part in joint nuclear vendor supplier briefing. So with the link on the chat, please move to the webinar for that session. And next session is to be started from 20 minutes past 4. Thank you.
It
is time to resume. So I'd like to now start panel session 2C, the supply chain, strengthening of supply chain. And we'll be talking about the countermeasures against disruption of supply and also the continuation of business. And once again, the facilitator will be served by Hiroko Kondo. Thank you. I shall be serving as the facilitator. I am once again Hiroko Kondo of Matrix K. So we'll be talking about the industry initiatives to deal with the supply disruption and obsolescence. So I would like to have the panelists make a presentation on this topic. So first of all, from JEMA, Mr. Ozawa, the manager of a nuclear division, will be making the first presentation. Mr. Ozawa, please. Thank you for the introduction. My name is Ozawa from JEMA, Japan Electrical Manufacturers Association, and I'm very grateful for this great opportunity. So I'd like to talk about the efforts to maintain quality while allowing the industrial commercial products for nuclear grade usage. So if you look at this slide, this is an excerpt from the nuclear subcommittee material. So the light water reactors was a technology that was imported from the United States. Mihama Unit 1 and for BWR's Tsuruga number 1, those were started in 1970, March 14th. Very day today, the start of commercial operations started. So we have been trying to manufacture the products in these reactors domestically, and we have achieved full domestic production. And this is a slide when the GX was first announced. Since the accident, there have been no construction activities of reactors. We have been trying to go overseas for activities, but it has taken a long time. And it will take a significant amount of time before we'll be able to maintain the technology. And also the people who have experience in construction are aging, as you can see on the graph. And if you look at the next slide, we're talking about the size or the number of companies who are members of JEMA, and also well, the technology and the supply chain that have been built over 60 years is now facing a crisis, as you can see, because many of the nuclear suppliers have been withdrawing from the business. So it has become difficult to maintain the quality within the supply chain. So one of the options is to use commercial grade products to a nuclear application. So the JEMA members have developed a structure, as you see here, and as a project consigned from METI, we are now engaged in developing a process model and also to draft a guideline for commercial grade dedication. In the development of this model, in 1979, there was a TMI accident, and we are using the expertise from USA, which overcame the TMI experience. And the suppliers of CDG, Hitachi-GE presentation after me, we will talk about the details, but from the supplier to the customers, we will be setting up a process in an optimal way so that the burden on both the suppliers and the purchaser will be reduced. So we want to share this recognition with all the suppliers and also with the nuclear operators so that this will be an industry-wide effort. And if there are any issues, then we need to overcome them with the all-out effort by the industry as a whole. That is all from me. Thank you.
Thank you very much. Next, from Hitachi-GE Nuclear Energy, Executive Vice President, Mr. Koichi Machida, will make presentation. Mr. Machida, please. From Hitachi-GE Nuclear Energy, I am Machida. I'd like to talk about our initiative to apply CGD in Japan. So this is about the commercial grade dedication of CGD. In one word, the buyers will evaluate commercial grade products and to verify them to be able to have this used in nuclear facilities. If this is not used, then suppliers are the ones that would provide quality assurance. They the buyers would buy the nuclear grade products, and they also do the verification and then provide to nuclear facility. And the nuclear quality assurance would involve QA manual, system, literature, records, and non-compliance response. So this has been a great burden on the part of suppliers. But once CGD is introduced, then supplier would come up with supplier standard quality assurance. And so the commercial grade items will be provided to buyers, and it's the buyers that would do the evaluation and verification and conduct quality assurance to deliver this to the nuclear facility. So on the part of suppliers, the burden is much less. So that's about what the CGD is about. So how are we going to go about doing this? This process is shown here. So by documenting and verifying the critical features to maintain the quality level. So with the CGD, you identify safety functions, and in safety functions, what are the critical features that are identified? And then you select the verification methods and do the verification and document them. So if I take an example of a manual valve, you can see at the bottom. So there's operation function, isolation function, and pressure resistance function. So those are the critical features. So operability and size, the dimension, is the operational function. So you have to do the testing and inspection analysis for size dimension so that you can maintain and leave the evidence to secure and assure critical features. So if you apply this process to use CGD, what will be the effect and impacts? The suppliers can see the management efforts reduced, and the buyers can have the products that can be delivered with assured quality. And as for so the management efforts are reduced, so you can actually shift from nuclear quality management system to ISO 9001, which is a commercial grade level. And then literature requirements will be reduced, and the inspections can be reduced. And you don't need the facilities and personnel dedicated to nuclear energy. And after the supply, the non-compliance response efforts will be also reduced. But impacts is that the entry barrier for general industry to take part in nuclear business is lower. But actually, they are only the specific items. And so for buyers, they have more options to seek products from. And the impacts could be that supplier support at the time of non-compliance could be limited. But by sharing the critical features with the suppliers, you can actually have traceability and record of quality control. Now CGD has been beginning to be used, so let me show you the examples. CGD can be used in various product categories, and it has proven to be effective. So on the left, you see 4 categories: simple electric items, for example, lead switch, and complicated electric items like motor-operated valve drive, and simple dynamic equipment, exhaust fan, and complicated static equipment, manual valve. So with the support from the financing by METI, we have already confirmed that this can be used as CGD. So we have a wide range of items that can be subject or entitled to CGD, and so the products that have become difficult to be supplied as nuclear material or with the change in design, there's no more suppliers. In those cases, you can use CGD. And what is also the beauty about this is that you can use this at all kinds levels of supply chain. We as plant manufacturer can become a buyer, to have the product delivered from primary supplier. But as Okano Valve explained later, the primary supplier could become a buyer to have a delivery from secondary supplier, where CGD can also be applied. So I talked about our domestic efforts in CGD. Now about Hitachi-GE's initiative in this area. In order to maintain and enhance supply chain, we have been proactively facilitating CGD, and we will continue to do so. On the left, we have done the questionnaire survey over 171 suppliers. What would be the items that would impact your decision whether to continue nuclear business? So there is order volume and order frequency, and also difficulty in handing over human resources, talent, and technology, and also management items like audit and checking items are too many. And when there's an issue, you have to you could be held responsible. So these are the ones that could affect the decision to continue with the nuclear business. So in order to promote CGD was a commitment from the top management. We have established the dedicated department for supply chain management to promote CGD. And that's called Supply Chain Management Office in our company. So they are giving education on CGD to design department, and also CGD standard operating procedures are put together, and they also select which products CGD is applied to, and also hold CGD briefing to suppliers to facilitate the use of CGD. So that's all from my presentation. Thank you.
ありがとうございました。
Thank you very much. Next, I'd like to invite Mr. Hitoshi Ichida, who is the director at Okano Valve Manufacturing Company Limited. Good afternoon. This is Ishida from Okano Valve Manufacturing. I'd like to talk about how we studied the introduction of CGD for nuclear-grade items. So the background. After the 2011 earthquake and tsunami, for more than 10 years, some of the items we haven't been sourcing. And then so there's question whether we can source from the same supplier in the same way as before. We also know that there are suppliers, actually a considerable number of them, who have stopped supplying to nuclear. So we actually did a search on the nuclear-grade items that we were sourcing and looked at possible alternative supply sources if necessary. So there are 139 important items now of nuclear grade that we have been sourcing. And 80 actually of the catalog or off-the-shelf items can be supplied, but then there were 13 such items that will no longer be supplied. And then there are items that involve special requirements, and there were 46 of them. Of them, 37 can be supplied by either an existing supplier or an alternative supplier, but there were 9 items that really need serious consideration as to how to source. So there are a number of issues identified. So usually when you think about equipment that has safety-related functions, there will be equipment qualification. And so even if they are commercial-grade items, we would have required suppliers to make special arrangements. But that has become more and more challenging. For example, some of the items were actually discontinued, and we will need to look for an alternative item and redo the EQ. The second case is that the suppliers can provide normal specific items, but not with special requirements or nuclear-grade quality control. The third case is for made-to-order items, and the supply or the procurement volume is no longer sufficient for suppliers to continue supplying. And then the fourth category is items that were not controlled as nuclear grade before, but now there are additional requirements related to severe accident preparedness. The fifth case is that there are new items and they are not nuclear grade controlled. So we look at actual case of where we've had challenges. So there were items. There was this supplier that we had not asked for nuclear grade control, but now we asked them to actually introduce JEAG 4121. That's a management system for nuclear safety. We also requested that we conduct on-site inspection, but then the supplier responded that that's difficult for them to do. So what's happening is that our people are actually going there to their site every time to conduct the inspection, nuclear grade inspection and monitoring directly. Another case is for new items. So with severe accident, there's this new reduction gear that we now need. And again, this reduction gears, if we can use commercial grade items, that means that we have a wider supplier base to choose from and wider product base to choose from. But then we are to ask the quality management system introduction. Some of the suppliers may not always be able to address that. So given all that, CGD could be a solution to those issues. So, for example, there are suppliers against which we had never requested nuclear-grade quality control. And with CGD, we can allow that supplier to supply in the same way as they were doing before. And for us, the advantage is that we can continue working with that same supplier. And if we are to source a new item, then that will mean that we have a wider choice, that we can source from a wider supply base. But then there are impacts that we'll need to consider. For example, for commercial grade items, the items that are controlled are just those that are controlled by commercial grade products, and that would be up to suppliers. For example, if there's an issue and we need cooperation from the supplier, maybe that cooperation may be limited and we may not be able to get the information we need. And the treatment of commercial grade items in issue cost analysis and assessment of quality, that could be a challenge. And there are some assumptions or preconditions for CGD, and it's that the end customer, the buyer, supplier, everyone in that, everyone engaged needs to understand the CGD process. And obviously, that would allow us to use CGD and introduce commercial-grade items with the minimal burden on the suppliers. But then there are advantages. One is that the buyer can actually do the assurance of quality in the place of the original supplier, and it will actually allow the buyer to look at a wider supplier base, and the new supplier will not have to fight that burden of additional nuclear grade quality management and whatnot. And so that would mean we as buyers have more choice, and we may have a stabler supply base while maintaining the quality of the items that we supply to the nuclear utilities. And so it's very important that the end customer, the supplier, everyone really understands the CGD process, and that the supplier's responsibility may have to be limited, and we need to build an acceptance among the stakeholders about that. That's all from me. Thank you very much.
ありがとうございました。
Thank you very much. Next, I'd like to invite From IHI, Mr. Tomoda, the General Manager of the Quality Systems Department of the Nuclear SBU. Mr. Tomoda. Thank you. I'm Tomoda from IHI. Thank you very much. At IHI, we use a Japanese domestic supply chain, but we have actually have an experience in CGD for some American products. So I would like to talk about that first. So there is a difference in the dedication of commercial grade products between U.S. and Japan. So in the U.S., there's a regulatory requirement based on 10 CFR 50 Appendix B and also 10 CFR 21. But in Japan, just recently in 2020, there were a new law that was stipulated for the quality management of nuclear facilities. So it is called the quality control regulations. And there is a mention of a CGD and how the commercial grade products can be applied to nuclear. And as for the implementation criteria, there is a EPRI guideline. So, and this is something that is endorsed by the NRC as well. So this is used, but in Japan, as was mentioned by JEMA, there is a guideline, and this is based on the EPRI guideline. So the process itself, included in the JEMA guideline, is very similar to that of EPRI. And how it's been implemented, well, in the United States in the 1970s, and since then, the guideline has been developed. And as was mentioned, after the 3 Mile Island accident, as a way of avoiding a disruption of supply, this CGD had been utilized. It not only hurt to acquire products, but that they have been use of a CGD for broader options. But in Japan, this is not something that is well known in Japan. So I think it is necessary to expand the usage in the Japanese market, and I think our experience vis-a-vis United States may be useful for the Japanese market. Now, this is some of the example of CGD implementation by IHI. So for IHI, since about 2008, we have been developing and delivering the containment vessel body and associated components, such as the equipment hatch and the airlocks for the personnel and so on, as well as the steel modules to be installed in the containment vessel. And in the United States, there is a definition of a nuclear safety-related equipment. If that function is lost, then it may have a substantive radiation effect in the external environment. And if that is the case, it's a safety-related equipment, and based on 10 CFR 50 Appendix B, the product would have to be made based on that appendix, or it would have to be certified as officially dedicated product coming from a commercial grade product. Now at IHI, we are providing airlocks and the equipment hatches that's associated with the containment vessel, and we also are manufacturing rubber O-rings, which is also a part of the safety significant equipment, but there are no suppliers in Japan that would make this O-ring that complies with the 10 CFR 50 Appendix B. So we have decided to use a rubber O-ring that is produced in Japan as a commercial grade product, and using the EPRI guideline, we want to supply it as a nuclear grade product, and we have that experience. And this is on the left-hand side, the guideline by EPRI, and on the right-hand side, what I've just talked about, that the 10 CFR 50 Appendix B QA program would have to be used. to make sure that this commercial grade product is equivalent to nuclear grade product. So this is the actual experience that we have at the IHI, and as was mentioned by Okano Valve presentation. So there are some properties that would have to be met to be used in CGD, but there would have to be an environmental consideration. So we have a irradiation facility, and also we have a heating facility, and we bring our product to test the properties of the product and perform like a tensile strength testing to see it has not degraded. And after verifying the quality, then we can ship. And there's expectation that we will be able to perform CGD towards the United States. So there's some considerations that we have to make compared to the use of a catalog of off-the-shelf products. So it may be a little bit more costly. But if you're using this product frequently, the same product frequently, or if it is possible to reduce costs using sampling testing, then it will be possible to reduce costs overall. So it would broaden the options. So finally, in Japan, there is a quality management rule that enables a commercial grade product to be used in nuclear applications. And there is a JEMA guideline that is based on every guideline. And if that can be used more broadly, and as long as the conditions are cleared, then it will be possible to supply these commercial grade products to the nuclear facilities. And for the dedicating entity, it will be possible to develop human resources. The operators will be able to have measures against part supply disruption. And I think for our suppliers, and the dedicating entity will be able to go overseas for their projects. Thank you.
Thank you very much. As was done in the previous sessions, we'd like to ask for the comments from the panel members based on what was discussed. And as a panel member, Mr. Hayato Inaguma from Agency for Natural Resources and Energy will join us as well. First, the importance of CGD in Japan is the topic that we'd like to address first. Machida-san from Hitachi-GE, the overview of CGD and applicability of CGD in Japan was presented, but it is getting difficult to maintain and secure a workforce. What was the background for introducing CGD? Can you explain once again? I am Machida from Hitachi-GE. With regard to the background, as Ozawa-san from JEMA explained, so the turning point was the March 11th earthquake, and demand has declined since then, and there are suppliers that are reducing their nuclear business or withdraw from the business completely. So we had to look for substitutions and then train them and get them to catch up. But in order to have nuclear grade certification, it's not just simply keeping records and documentation. It takes a lot of efforts, including time and money and people. So since the March 11th, 2011, the supplier's voice is getting louder and louder as over time, and we had the sense of crisis that we were not able to continue with our business. So we asked Mitsubishi and IHI and Toshiba to get involved with the support from METI and work with JEMA to promote CGD. Thank you very much. So now the question to Ishida-san from Okano Valve. The supply chain supply for CGD is now getting more realistic. So can you give us your perspectives as a supplier? I am from Okano Valve. As I said in the presentation, in our company, in component procurement, the continued delivery or supply is now getting more difficult. And the BWRs are expected to be restarted going forward. And also, in order to respond to advanced reactors that were presented previously, we are now accelerating our efforts to look for substituting items, but it is quite challenging in the field. So the nuclear grade maintenance is, as compared to other industries like thermal industry, is far heavier in workload than people would expect. So if the CGD proceeds, then we can reduce the overall burden on the part of the industry. So we hope that CGD application will be quickly promoted. And thank you, Ozawa-san from JEMA. So based on what was discussed as industry trade association, what is your view? Thank you. I'm Ozawa. So after the March 11th earthquake, for 10 years, we had been emphasizing the necessity to construct new plants. But we thought that it would take time to actually get that translated into the supplier's business. And even if you publish the CGD standard, it has not been well recognized. And there might be some people who are still questioning the validity of CGD. So as industry, we have to first and foremost broaden the understanding and seek understanding so that this could be on the stage of business negotiation. And for the government, we have to ask them to actually pat our back and sometimes inject some money to support us. So the industry has to get the government involved as well.
それでは次に、
Thank you very much. And now I'd like to perhaps ask for comments about experience in the United States and what that would mean with regard to what the Japanese supply chain can learn. So Tomoda-san from IHI, you've experienced the CGD process in the United States. Perhaps if you could highlight the difference between the two countries and what you think would be key to make sure that CGD is widely adopted in Japan. Thank you very much. This is Tomoda from IHI. With regard to the difference between the United States and Japan, as I explained earlier during my presentation, back in the 1970s, the United States began CDG, so they have a longer history. And the U.S. regulation is not just about utilities, it also extends to suppliers. That means that the NRC, the regulator, really needs to rationalize and streamline their regulation project, and they have a very open review standard, and they are also endorsing the guidelines from the private sector, like the EPRI guideline, and that has led to the utilities in the United States taking the lead to leverage CGD, and that extended to an industry-wide effort. Now, in Japan, for us to expand the use of CGD, one aspect would be to really have an industry-wide effort, which would involve the regulator as well. The second point, currently, in Japan, we may say, okay, CGD, but there aren't much opportunities for business just within Japan. So we might want to involve or encourage the suppliers to actually get into the United States business and use the CGD, and that would probably mean less of a burden or hesitance to use CGD in Japan too. Thank you very much. Machida-san from Hitachi-GE. This is a question for you. So CGD is allowing commercial grade items to be used, but then wouldn't the suppliers worry that their business base be lost to other commercial grade suppliers? So Hitachi-GE obviously has a wide supply chain that supports them. I'm sure you have insight into what the suppliers' thinking would be. Thank you very much. In the United States, CGD has been used for a long time, as far as I know, at least for 30 years. IHI said that that started back in the 1970s, so that's actually longer. But, in a nuclear facility, not all items can use CGD. CGD is really a system that would help the nuclear utilities to make sure that they can have a supply. So it's really avoiding the supply disruption or obsolescence issue from the viewpoint of the utilities side. And so the nuclear suppliers that have the core technology, we hope they would continue supplying their items. And for such suppliers, I think that would actually alleviate some of the burden with regard to the nuclear grade quality requirements. So I'm sure this will actually be a benefit to everyone already in the nuclear supply chain. Thank you very much. So with that, I'd like to transition into the summarization or wrap-up of the session. We looked at what measures can be taken to prevent supply disruption or parts of obsolescence and focused on CGD. So Inakuma-san from our Agency of Natural Resources and Energy, would you like to perhaps give a summary comment? Thank you very much for that. The CGD may be a new word for many of you here, but for those who are leading the industry efforts, they are looking at the challenges, and we hope that we have helped everyone understand the benefits of CGD. We appreciate all the presentation. For METI, we would like to provide financial assistance so that the CGD can be taken up more widely, and we appreciate the development of the CGD guideline. But then we will need to just continue to build up small steps so that we can become like the United States with regard to leveraging CGD. And so we will try to help get the first case in Japan. So we will work with the plant manufacturers, suppliers, and the utilities so that we can support CGD from behind. It's not just about CGD. There are other aspects like digitization, use of 3D manufacturing or 3D printers or additive manufacturing. And if you look broader, supply disruption or obsolescence is actually tied with skill transfer and generational handover. And this is actually related to the international market. Without people, talent, you can't actually hand over the technology. And even if we have resumption of nuclear builds in Japan, there would be challenges in Japan as well. So, if there's a lull or vacuum period in construction, there needs to be assistance from the government sector, and that's what we would like to do. Just 1 year ago, we announced the establishment of the nuclear supply chain. After a year, we have actually doubled the number of participants in the platform, and we are very happy about that. Actually, all of METI work together, not just the ministry in Tokyo, but the regional bureaus as well. And JSW in Hokkaido, Okano Valve in Kyushu. We actually worked with more than 100 suppliers. We actually physically visited all of them to have discussions. So from the ministry side, everyone talks about the importance of supply chain, but it's easier said than done, and it's not an easy problem to solve. So we understand that this is really a long-term effort that we'll need to continue to work on. Outside of Japan, for a long time, there was a vacuum with regard to new builds, and then they had difficulty establishing their supply chain, and that's actually leading to longer construction times outside of Japan. And in Japan, as we try to introduce more innovative and new reactors, we will need to be prepared for that challenge. Last but not least, we are actually METI has never been involved in such a large event for 2 years in a row. It's actually rare. So I hope that people would understand that this is a show of the level of commitment we have in this particular field. And with this, I'd like to conclude my remarks. Thank you very much.
セッションの総括
Thank you very much for that, Mr. Inakuma. And with this, I'd like to conclude the session. Thank you very much, the panelists, and thank you very much to all of you in the floor, both physically and online. Thank you very much.
近藤様、パネリストの
Thank you, Ms. Kondo, and members on the panel. So, Ms. Kondo and the members on the panel will be going back to their seats. Let's give them a big round of applause.
それでは最後に
Finally, I'd like to invite the president of JAIF, Mr. Shiro Arai, for closing remarks. Thank you very much for your participation in this supply chain symposium. My name is Arai, the president of JAIF. And upon the closing of this nuclear supply chain symposium, I'd like to give you a few words upon the closing. Last year we held a symposium just after the policy was put out on the supply chain management and strengthening. And now I'm very grateful that we were able to hold the second symposium. And we focused on the important topics related to supply chain in the nuclear industry, namely government support, overseas business development, and supply disruption measures. Session 1. We discussed the future of the nuclear industry. So we talked about the next generation advanced reactors, and also we heard about the capability building experience in France. In session 2, we focused on the supply chain development initiatives. And 2A, the topic was human resource development and security. And we heard about the various efforts made by companies and organizations. In session 2B, the topic was participation in overseas projects, and there were experiences shared about the initiatives in the industry and participation in various occasions. And we were also able to discuss the issues around the supply chain building globally. In session 2C, the topic was supply disruption and obsolescence. And there was an introduction of the concept of commercial grade dedication, and we were able to discuss the applicability of that in Japan. So there was a very useful information shared, good practices also being shared, and I think we were able to gain a very good insight to be the basis for future development of this industry. And I'm very grateful for Ms. Hiroko Kondo, who served as a facilitator for each of the sessions. This kind of an opportunity for information exchange will be an opportunity for us to find new approaches and new solutions to the challenges that we face. And we were also able to hold a briefing session for the young and energetic students, and we were able to communicate the future prospect and also the attractiveness of the industry. So we want to continue to outreach the new generations so that we will be able to invite these future leaders into our industry. So thanks to your great efforts and cooperation, we were able to successfully conclude the second Nuclear Supply Chain Symposium. And I'd like to express my heartfelt gratitude to all of you. And I do hope that this opportunity would be contributing to the future development of our nuclear industry. With that, I'd like to close this symposium. And once again, thank you very, very much for your participation.
ありがとうございます。
Thank you very much. With this, the second Nuclear Supply Chain Symposium is adjourned. And those of you who are here in person, I will be sending you an email for your feedback. So thank you for your cooperation in responding to that survey. And those of you who have participated online, there will be a questionnaire survey after this session is over. So thank you for responding to that questions. And those of you who are here in this hall, please make sure to leave your simultaneous interpretation receiver units on your table. Once again, thank you very much for your participation. And thank you to those participants who were joining online. You can exit the session now. Thank you.